Welcome to this tutorial on Git. Whether you're just getting started with Git or you know Git already, there's going to be something you'll learn from this tutorial. In this tutorial, we'll be using GitHub for doing our Git practice exercise. However, the same commands will work with Azure Repos, Bitbucket, or even a private Git repository. In this tutorial, we'll start from very scratch and understand how to initialize a new Git repository, how to stage your first changes, how to commit changes locally with a commit message, and I'll show you a trick where if you did get the commit message wrong, how can you use the amend command to correct the commit message. We'll then look at how to create a remote repository on GitHub, how to push changes from your local workspace up into GitHub, how to clone a new repository from GitHub down locally on your workspace. We'll cover the branching workflow. We'll cover how can you commit changes to a new branch, how do you check out a branch, how do you push changes to GitHub? And we'll also cover a bit of a workflow where what if you wanted to commit selective parts of a changes? We'll look at the diff command, we'll look at the merge command, and finally we'll clean up by running a delete command on the branch and tidying it up. So stay tuned in the next 20 minutes from nothing to everything on Git. Let's get started. Alright, so let's start off with the git init command. The git initialize command, or the git init command, is used to initialize an empty Git repository. Now in this example, we'll start off with a blank directory, create a new file, and then run the git init command, which will create a folder in that directory. Now that folder, when it gets created, is actually hidden, so unless you have the view hidden folder settings enabled in file system, you won't see it. This folder contains the Git metadata as well as the Git configuration file. Let's check it out in this example. Let's start off by checking the version of Git. We'll run the git --version command. Let's make a new directory. We'll run the mkdir command. We'll call it git demo. Let's change directory into this new folder. I'm gonna run the touch index.html command to create a new file named index.html. It's empty, doesn't have anything in it. Let's just create a simple HTML structure to it. So we've given it a header. Let's close the HTML bracket. Let's run the cat command and we can see the contents of the file. As we open up the folder in that location, we see that it just has that file. So I'm going to run the git init command, which will initialize a new Git repository. Let's open this up in Visual Studio Code and we can see the file as well there. Coming back to the command line. Next up, let's check out the git config command. Now the git config command persists the git settings. The great thing about the git config command is that you can specify global settings that will span across the machine or the user profile, and then you can specify local settings that are pertinent to the Git repository where you've created the local config file. So let's take an example. If I have my personal projects as well as my professional commercial projects in Git repos on the same machine, I probably don't want to be doing my commit with the same email address and the same name. And so what I can do is in my Git global config file, I could decide to use my personal Git username and my personal email address that I want to show up in my commits. And where I have my professional repos, commercial repos, I can use my work email address. So the best thing to do would be to specify git config global with the user.name, and I can specify my name there. And then where I configure this on the local level, I could run the git config -- local switch, which will apply these settings to the local file only. So let me give you another example of using the git config file. Say for example, you did not want to use the default branch name as master. We understand why, right? So you could go into the git config file and change the initialize branch name from master to trunk or main, right? So that's another setting you could persist. There are a lot of other settings, so it's worth toying around and dabbling with it a little bit. But let's check out what git config does and how it works. Okay, so let's run the git config command. We'll use the global switch this time, and with using the global switch, we'll specify the property user.name, and this is to specify the name that will show up on the commits. So let me use my name here, And then I'm going to specify with git config in the global config my user.email address, and in this I'm going to use my personal email address, so that'll be foo@foo.com. Now to see all the git config settings at the global level, I could run the git config --global--list, and you can see the two settings for the name and the email address show up there. Okay, let's clean this. Now let's run the git config command with the local switch, and see I'm running this in the context of the specific Git repository that I created for this demo. In this case, let's specify the user.name for which will show up when we do the commits as Azure DevOps TV, and let's specify the email address as az@devopstv.com. Now let's run the command git config --local and --list to actually see the configuration, and as you can see there, over here we have a different username and a different email address to the one in the global. Let's take another example. In this setting here, we will, in the local git config, update the default branch name to be trunk. So if I run the list, you can see that that additional setting has been specified here. And if I run the same comparison back with the global, you'll see in the global one it's called main. The name is different as well. Alright, in the next section we're going to cover quite a few commands together. We'll talk about git status, git add, git reset, git commit, and then git log. If you look at any general Git workflow, you would start working on a file in a workspace. You may be in a folder, you may be outside in a nested folder. When you run the git status command, it will show you a list of all the files that are yet to be committed in your local workspace. Now, once you have seen the files that haven't been committed, you have the option there to run git add command, and the git add command can be run with a dot in the end, in which case all of the files get added as in staged. And the purpose of the staging here is to indicate that you are now showing the intention to commit these files in the repository. If you didn't want to commit, if you didn't want to add all the files, you can selectively specify the name of the file or use a collection of wildcards to add and stage multiple files together as well. Git commit command, as the name suggests, is to commit all of the changes that have been staged into your local repository. You could backtrack a little bit and use the git reset command instead of the git commit command, which will unstage all of these changes back into the workspace, and then they're not tracked anymore. Once you've committed your changes, you could run the git log command, and the log command can be run with a number like -1 or -2, -3 to see the history of last 1, 2, or 3 commits. And you can also run it with a switch -- graph or one line, wherein it will show you the history in a very pretty format. Okay, so let's see all of this in action. Let's run the git status command in our workspace. Git status tells us the branch we're in. It tells us we have no commits yet. It's also telling us that we have index.html file, which is not being tracked yet. Now, instead of tracking that file, I'm going to create another file. Let's call it the page1.html. I'm going to add some text to it and output that back into the file itself. Okay, let's see the contents of this file. If we run the git status command now, and then follow that with the git add command, now we've specifically added the index.html file, but we haven't tracked the page1.html. If I run the git reset command, both of these files will stop being tracked and will show as untracked. As you can see, index and page1 both are showing as untracked. Let's run the git add dot, which will add both of these files into staging, and as the status command indicates, both of them are now being tracked. Okay, we're ready to commit these changes. We'll run the commit with the -m switch to specify a commit message as well, and it's commits the changes on our workspace. If I run the status command, it says I've got no pending changes locally. Now I can run the git log command with the switch one line and graph, which will in a very pretty format show us the commit number and the commit message that was used. Now this is an interesting one, and it keeps coming up time and again, where you may have committed something with a message but realized the message wasn't right. You can run the git commit command with the amend switch to update the commit message that you had previously used. As you can see on your screen, the message has been updated. The committed changes are in our local workspace, but changes in our local workspace are as good as the state of our laptop and the health of our hard disk. What if either crashed? The changes would be lost. So it's only sensible to push these changes upstream into a remote repository up in the cloud somewhere. Now in this example, we're going to use GitHub, but you could use Azure Repos or Atlassian Bitbucket or a private Git repo elsewhere. The intention really is to have an endpoint which is out there somewhere acting as the origin and the remote, and we will basically take that URL and specify that as the upstream source within the Git config, so that the repository is aware of the upstream branch that it needs to push the changes into. And then following on from that, we'll run the git push command to push these changes from local to the upstream. And then we'll follow the rest of the workflow to just check the status and make sure from there we're able to sync the changes across. So let's check that out. If I just run the git push commands, it tells me that I don't have an upstream configured. Therefore, it does not know where the changes need to be pushed up to. Let's go in GitHub and create a new remote repository. Let's call that remote repository Git tutorial. Let's specify a brief description about that repository. We'll change that repository to be a public repository. Let's keep all the other settings the same and click accept to create a new remote repository. Let's copy the address of the GitHub repository, and now we'll run the git remote command to add origin by specifying that endpoint address. Now we can verify the upstream origin configured in a local repository by running the git remote --v command, and you see it's telling us what is configured as the upstream remote for both fetching as well as the pushing the changes. So now if I run the git push command, and I have to use the -u switch so that it remembers that this is the upstream that's being configured for both pulling and fetching the changes. And you see all the changes have been pushed up. And when I now run the git status command, it's telling me that the branch is up to date with the origin. Let's go back to GitHub and refresh the page. We can see the two files that we created are kind of showing up there with all the contents obviously, and it's telling us when they were last updated. Now I'm going to come in here and make a change in the file on the remote, so you can see these changes are actually directly being committed in the Git repository up in GitHub. Let's commit the changes. If I run the git status command locally, it is not aware of the changes that had happened on the server, and they don't reflect even if I run the history, because it's running the history on the local. Now if I run the git fetch command, it's going to reach out to the upstream and probe to see if there are any more changes there which aren't yet available in the local repository. And it's clearly tracked that the origin has moved forward from where the local repository is, and that's why it's saying there's a new git hash number of the commit there that we don't have available. Let's follow the workflow on and run the git pull command. It pulls the changes down in page1.html. Now if I run the git log command, you see it's in the history showing the additional commit that had happened directly on the server. Okay, now in order to show you the git clone command, I'm actually going to delete my local folder. So I don't now have a local git repository that I've been working on, and now I'm going to run the git clone command. But in order to do that, I'm going to need the GitHub URL for the repository. Now I'm using SSH here, so I'm going to do a git clone and specify the GitHub remote address, and as I do that, the repository gets cloned. Let's change directory into the Git tutorial folder, and we have cloned the repository successfully. Just to show you it's the same repository, I'm going to run the git log command and print out the graph. You can see it's just got the 2 commits that were previously committed. Let's run the git branch --list command, which will list all the branches currently in our Git workspace. Let's create a new branch called feature. Let's run the list command again, which will show us that we now have 2 branches. Now we'll have to run the git checkout name of the branch, in this case feature, to check out the feature branch. As you can see, feature is being highlighted, stating that it's now the checkout branch. Let's clear this. Let's have a quick look at the status. So it's telling us our branch is fully up to date. There's nothing to commit. The working tree is free. We can look at the history of the feature branch. It will have all the contents that the original main branch had from which we created this branch. Let's check the remote mapping. We can see the repository is successfully mapped out to GitHub repository from which we've originally cloned. Let's start off by creating a new page in this new feature branch called page2.html. Let's enter vim and add some HTML content into the page. So purposefully, let's add very limited content, and let's save and exit. Let's just do a quick cat to see the contents of the page. As you can correctly see, when I run the git status command, it identifies the page as not been staged. So we'll stage the page by running the add page2.html command. And if I run status, you'll identify that it recognizes the page has been staged. Now let's go in and make some further changes to this file. So let's change the markup in that file by adding the HTML tag and closing the HTML tag. Save and exit. Now if you run the cat, it's picked up the changes. If you run status command, it says there are further changes that are yet to be committed. By running the git add -p command, I can selectively pick which parts of the changes within the page do I want to stage. As you can see here, it's giving me the option to identify the hunks of the changes that need to be staged. So I've only selected the first part of the hunk, which is the opening HTML tag, and then decided to ignore the second part of it. So that's an added command over the git add, which we've previously walked through. Okay, so let's check the git status now. We can see our page is staged, and we can run the commit with the -m switch by specifying a commit message. So we've locally committed the message. It's time to push it up. Now as I run the push command with the -u switch, you would notice I have the option of specifying the branch name here, and I will specify feature. But when I run this command, it fails because the feature branch yet does not exist on the remote. So I need to run the command git push -u origin with the name of the branch, which in turn creates the feature branch in the upstream as well on GitHub. As you can see in the output here, it says, okay, a new branch has been created as part of this push request. Let's run the git branch command with the list, and this lists all the local branches. If I run the same command with the -r switch, it shows all the branches on the remote as well. So we can go back to GitHub, and you can see if I refresh the page, we actually have 2 branches, main and feature. And feature has the commits that we pushed upstream. You can see features checked out at present, so I'm going to check out the main branch, and I'll show you how we can perform a diff operation to see the differences between the 2 branches. So by running the git diff name of the branch, the current branch is compared against the other branch. And obviously there are some changes. Now we can run the git merge command, which will essentially merge the changes from feature into the main branch. As you can see, because there were no conflicts, the features have been merged. If I check the status, you can see the branch is up to date. If I run the history command, you can see another commit has been added to the main branch, which has come in from the feature branch. It's got the commit number on it. It's got the name of the source branch in it as well. Now at present, you would see these changes are still merged locally. They're not there upstream. Obviously, to push them upstream, we would have to come back to the command line and run the git push command. And as we do that, the merged changes are pushed upstream into the remote as well, at which point the workflow is complete. And it reflects that in the status history there. Let's refresh the page, and there you go. The merge is complete on the remote as well with the push command. At this point, we could delete the feature branch because we don't need it anymore. We can run the delete command, or you could use the -d switch, which would perform the same operation. It's a safe operation, so if there are any pending changes, it essentially just does not delete the branch and gives you a warning in turn. So that brings us to the end of a simple Git workflow, wherein we started off by creating and initializing a repository locally in a folder, creating a handful of files, staging them in a repository, committing them locally in a repository, going off to GitHub, creating a remote repo, publishing the changes to the remote repo, and then after that we went through the workflow of deleting the local workspace, cloning a new repository from the remote workspace, creating a new branch, checking out the branch, making some further changes to it, committing them after staging them, doing partial staging where we sort of identified sub changes within a file and added the hunks and staged them and committed them, and then finally doing a push by creating a remote branch, and then at the end of that going back to GitHub and checking that the stages were fully synced, and then coming back, deleting the additional branch after merging it, and that is a typical Git workflow. I hope you enjoyed the video, one of many. This channel is always up to date on content around DevOps, so please don't forget to click the subscribe button, and I look forward to seeing you in the next video. Thank you.